9 to the 100 minus 3 to the 100. We want to find last two digits of this number. So first, 9 is what? Is 3 squared. Power of 100 minus 3 power of 100. So the power rule, we know that a to the m, the n equal to a to the mn. So 3 to the 2 to the 100 will be 3 to the 200 minus 3 to the 100. Okay, in next step, we want to find last two digits of this number, last two digits of this number. So we should pay attention to powers of 4. Because both of them are multiple of 10, let's find first 3 to the power of 10, last two digits. Let's calculate. 3, let's see, 3 to the 5 is what? Is 243. So last two digits equal to 43. In next step, we say 3 to the 10 is what? Last two digits is 43 times 43. Why? Because let me tell you, 3 to the 10 equal to 3 to the 5 times 3 to the 5. Why? Because a to the m plus n equal to a to the m times a to the n. And now 3 to the 5 is 43, 43. If we want to calculate last two digits, we write 43, we write 43. Pay attention, we have a trick to find it quickly. 3 times 3, 9, 3 times 4, 12. We don't calculate the rest because we want only last two digits. 4 times 3, 12. But we don't calculate the rest. It will be 49. So 3 to the 5 is 43. 3 the 10 is 49. Now the next step, we want to calculate 3 to the 20. Again, 3 to the 20 equal to 3 to the 10 times 3 to the 10. 3 to the 10 is 49. 49 times 49. Let's calculate. 49, 49. 9 times 9, 81. We have 8. 9 times 4, 36 plus 8, 44. And 4 times 9, 36. So it will be 1, 0. It's good. 0, 1. So we conclude that last two digits of 3 to the 20 is 0, 1. So because of this, we can say in next step, 3 to the 40, for example, equal to 3 to the 20 times 3 to the 20 equal to 0 times 0, 1 times 0, 1, which is 1 again. So 3 to the 40 is 1. 3 to the 60, if we calculate, again we will see it's 1. Why? Because you say 3 to the 60 is 3 to the 40 times 3 to the 20. Again, it is 0, 1 times 0, 1, which is 1. Now we conclude 3 to the multiple of 20 equal, let me write here, 3 to 20k, last two digit is 0, 1. Now, because 200, last two digit is 0, 1, and 3 to the 100, 0, 1, so it will be 0, 0. So last two digit of 9 to the 100 minus 3 to the 100 is 0, 0. It was solution number 1, and it was basic solution. Now I want to tell you a professional solution for solving problems like this. In solution number 2, look, you should know something like phi of n. Phi of n is what, for example? Phi of n is number of, let me write here some phi of 100 is from 1 to 100. How many numbers are relatively prime to 100? For example, like what number 1, 2, no, because 2 and 100 are not relatively prime. They have common factor 2. For example, 3, 4, no, 5, no, 6, no, 7, and 100 are relatively prime to 99. So the number of them, it has a formula. You say 100, because if you factorize 100, it will be 2 squared times 5 squared. You write 1 minus 1 over 2 because the prime factors of 1, 5, it is this. And if you calculate, it will be 100 times 1 over 2 times 4 over 5. And it will be 40. And one important thing for calculating, let me erase, for you want to find last two digits. If you want to find last two digits, 3 to the 40, we find that mod 100 is 1. Mod 100 means the remainder when divided by 100 last two digits. It is a theorem. We call it Euler's theorem. And we call phi of n Euler's quotient function. Euler's theorem, it says what? Because 3 and 100 are relatively prime, GCD of 3 and 100 are equal to 1, 3 to the 40 is 1. It is also correct for 7 to the 40, so this theorem is so much useful. Now we want to calculate 3 to the 200. Let me write with different color. 3 to the 200 minus 3 to the 100. So if we consider mod 100, then the first one will be 1, because let me write 3 to the 200 is 3 to the 40. 5 minus 3 to the 100 is 3 to the 40. 4 times 3 to the 20. It will be 1 minus 3 to the 20 mod 100. Now in this step, we should focus on calculating 3 to the 20. So 3 to the 20 mod 100, if we calculate this, let me write mod 100 here, more space. So we say it is 9 to the 10. And also you can say it is 81 to the power of 5. And here you can say it is 81 times 81 times 81 times 81 times 81. And then in next step, we want to calculate 81. So we can say what? We can say 81, 81, last two digits. 1, 8, 8. It will be 61. 61. Okay. Now we find 61 times 61. 61 times 61. 166. It will be 1, 2. So it will be 20. As easy as this. And then we want to find 21 times 81 in last step. 21, 81. It will be 81 to 0, 1. So it is 0, 1 or 1 mod 100. So the last two digits, the answer is 0, 1. So we solve this problem. Look, this problem was easy problem, but in hard problems, you have to use Euler's theorem and Euler's quotient function. So if you want to learn other ideas, send message to my WhatsApp number, and please don't forget to subscribe. Turn on the bell and like the video. Thanks. Bye.